Today we'll be looking at how to automate the migration of IBM Datastage jobs to BigQuery and DBT using SAS2Pi as the platform. We'll start by looking at what does a Datastage job look like. They're typically all XML files. PJB stands for parallel job. QJB is another format, it's a sequence. And there are various things that are in this XML. Each XML is describing the job and all the steps that it's taking, be it doing a select query on a database table, transformation on the database table, aggregations, sorting, outputs, inputs, everything is described in this XML. Naturally, this is pretty hard to read. So in order to convert it to BigQuery and then put it in DBT compliant format or DBT models, you can call it, we have several things that we do, and that's what SAS2Pi as a product brings all the automation to us. We'll look at the main UI to start with. So I was just showing you those PJB files. So the PJB files by themselves don't make any sense. So what do we do is that we parse those XMLs. And if I add this as a new project, right? Every project has many different data state jobs depending on the use case. Once you upload all the data state jobs, typically just using an upload to process the data set jobs, which are in the form of typically XMLs like PJB and QJB XML formats, is to parse them and convert it into a format which is actually the first step towards migrating to BigQuery. Once it migrates to BigQuery, then DBT model is created on top of BigQuery. We will look at it step by step. The first thing is, of course, these are the inputs for you. So the PJBs and QJB files, which are all XMLs, we take this as input, and then we go into SAS2Pi UI, we can create a new project. A project is simply an application, which is a collection of dataset jobs. Typically, this will be associated with a sequence or a QJB file, as you might call it, when you do data stage exports. So each such application has a UI where you can upload additional files, zip files or individual files. And as soon as you feed them in, we get this step where we analyze the files, and then of course we also convert the files to BigQuery and DBT. So let's look at what do we find once we do the analysis, and then we'll look at the details. First, let's look at behind the scenes, what happened when we clicked on it and we said analyze these files. The first thing that happens is all these PJB files and QJB files, which are all XMLs as we discussed. First we parse them and we convert them into more readable format, which is text file. At the same time, we automatically created SQL for creating tables or transforming or joins, whatever the stage in data stage is. We kind of do the similar or analogous conversion here during parsing, giving you pretty much all SQL output. This is the first step towards BigQuery, of course, because we need everything to be in a SQL format for it to fit into DBT models and BigQuery. Every single XML file which represented a job got converted into this SQL-friendly format by our parser. This parser is independent of any GenAI or LLM. There's no AI. It is straightforward parsing the XMLs and trying to create these SQLs. We do this first step. Once this first step is done, that's the behind the scenes. But this is what you'll see, that we know more about all your files. What are we looking at? Looks like we're looking at Oracle connectors and transformers. We can see some details about what kind of stages are being used in this data set job or jobs for this application. Using this, we can figure out many things, including the data lineage and any kind of dependencies. We can look at the file dependencies, for example, try to see are these files depending on each other. This is automatically detected because there is a sequence of these XMLs, and when we parse the XMLs, of the dataset jobs, we automatically figure out the linkage between the 3 jobs or 5 jobs or 10 jobs. So once we get to this level, we can also show you the data lineage itself. So data lineage is at the application level, so where we see all these details. I think these are some of the good ones. So this is Oracle. Some Oracle table is being referred here, so we kind of put it right there. Then there's a lot of advanced capabilities you can do on top. Like you can look at project files, you can just click on it and try to find the code itself, how this is being translated. So if you see this on the left side, you'll see the actual SQL that we created from the XML. On the right side, you'll see a DBT model for BigQuery just after converting it. So you'll see all the DBT models on the right side. On the left side is the pseudocode, I would call, which is after parsing the XML files. This lineage is also available at every file level. We can also see the data lineage file by file or job by job by just switching from project level to file level and then picking the specific sequence that you're interested in, then clicking on an individual file. Then it'll automatically do all that stuff for you. Let's do it right now. We'll say, can you create the data lineage within this specific job? So it did it. So this is very clear now, and this will be similar to what you would see on the UI for Datastage because we are following the same steps. We're reading two Oracle tables here, through Oracle connector as a stage. We're creating a couple of views here. Then we're doing the lookup here, join. That's what this is. Then followed by other steps before we output to Oracle. So this is similar to what your Datastage job will look like in the Datastage UI, and we are trying to uh, mimic that for the best scenario of understanding it, because we need to understand that this Datastage job has been converted correctly or not. So all this is just the analysis phase where we're just trying to figure out what happened to the dataset jobs, all the lineages, the dependencies. Once you figure out all these things, then we're ready for the actual conversion. You can do conversion here right at the top by just going there and saying just convert everything by just clicking convert Google BigQuery. And since we picked DBT as a deployment for this, that will create the DBT models for all the steps we found in the XML. If you want to look at it in more detail, this goes through this converter sequence, and sequence has 3 specific jobs. Each job will show you the code itself. You can look at how the sequels are written step by step from left to right. So you can look at all these details. You can see how the flow is and all this other stuff. If you have AI, you can also use this. We're assuming there's no AI, so we'll just leave it to this kind of a screen where it's actually telling you how the job is going to run. Similarly, the other files also have their own way. So we represent each job within the sequence similarly. The next step is to convert itself. So this is conversion. We strip BigQuery and then converts. It already converted for us. But if you see side by side, you'll see that this is the pseudocode of sequels we wrote from the XML through the parser, and then we converted that to DBT models, which will work with BigQuery at this point. You see that all this code, right side is all automatic. We wrote all that code. We also take care of these things. Any functions that need to work in BigQuery, like string to timestamp, will not work in BigQuery. So in BigQuery, we automatically parse the SQL and convert all those functions too, so that you have functional SQL for the DBT model on the right side from all this code on the left side. So that's the conversion part. And any given project you go into, any file, any job, you can say, we create the code and we show you the left and the right side. Left side is the pseudo code we have, right side is the converted code. So you can start looking into how this code will be written in BigQuery, including what we have is DBT. Once these models are created, well, then we can take the DBT models and start running in DBT. DBT Cloud is there right now, so you can just take it to DBT Cloud, put all these models there, and in fact we actually take care of those things automatically. So as we were doing one of these jobs, let's pick this last job that we looked at. So when we saw this, the code conversion is here, the outputs. So we create this data match for the data reconciliation and DBT project for the actual models. We'll show data match shortly. But these models first need to be executed, then we can do data match. So here you'll see all the individual jobs. Each job has many models. Depending on what it's doing, it creates multiple models. All these, there are 3 jobs here. So we have lots of models here, which are BigQuery, and then of course, they use DBT. So once you have these models can be pushed straight into DBT Cloud. If you have DBT Cloud, for example, by using our shortcuts here, you can do DBT compile, build, test, run, and then you can do git push. Once git push works, then DBT. Now that we have the DBT models for the BigQuery, these models can be pushed using git to DBT, and then the further execution and testing and everything goes on inside DBT itself. The next feature we need to look at is, let's say you did that successfully and then the DBT models have been running. Now you do have the old system where you're running the current Datastage code to write some outputs or generate some outputs. We need to also compare that the new system using DBT BigQuery is the same, like the outputs cannot be different. So we do have an inbuilt feature to do the data matching. So we just click here and then it'll tell you what the differences are between the data sets. Of course, you need to configure what you want to compare. So you can pick the sampling ratio, you can pick where is it before, where is it now. So let's say the old system is Oracle, so you'll pick Oracle as the source, and the target now is in BigQuery. So it'll be comparing the Oracle DB, all the tables that you define, to BigQuery. And the most important thing here is that what does the report look like? The reports are pretty comprehensive. So we'll show a few reports here. If I'm looking at this report, this is a data set job. This has 500,000 rows, 3 mismatched columns. So the rows were okay, the columns mismatched. So in this case, I'm curious to see what kind of mismatches there are. So here you'll see a whole bunch of details. These are the 3 mismatched columns. It even tells you the percentages of mismatches: account balance, transaction amount, and customer name. You can look further and look at exactly what the changes. So there's some difference in the value. This is a mode of decimal points: 794,282,804,149. So that's the difference there. So it'll point out all those things. And then if you want to go further, also after 7.6, 405 versus 554. So it depends on how deep you want to go, and then you can start adding exceptions. If the decimal point, you're okay with 2 decimal points or 3 or 4, you can add some exceptions so it doesn't flag everything as a mismatch. So that happens for every data set. So if it's passed, it passed. Otherwise, it'll tell you it failed. Using this, you will know whether your dataset job has successfully executed in BigQuery using DBT, because the data is all the same. The SQLs have been already converted. Of course, you can just go and check any given job and the code it wrote, then understand how it wrote it. You can just validate those things. So we have seen how we take the PJB, QJB, XML files. We have seen how we analyze and get all the details that we require for a successful migration. We saw the data lineage at project level and the file level. Then we saw the converter itself in action. And then finally, once you execute the job in DBT Cloud or DBT with Google BigQuery, we'll be able to compare the results to make sure that the data is still the same from when dataset job was executed versus the DBT model was executed. That concludes the quick demo.